Hello dears, good morning and welcome back to our physics class. Okay, so in the last class we have studied how the resistors and group of resistors connected in series, right? And how the better resistors are connected in series, how the potential difference vary or how the resistance vary and what happens to the current flowing through that circuit also. Okay, so now we are going to discuss the second arrangement, that means the parallel arrangement of resistors. So the resistors are in parallel. How we can connect the resistors are in parallel? Suppose if there is a resistance, if there is resistors having resistance R1 and R2 and R3. How we can connect these resistors together in parallel method? And we have a circuit that contains a battery or cell. Here we can take this is the battery, right? And provides some voltage to the circuit. And we have three resistors which are connected in parallel. This is R1, this is R1, and here we have this is R2, and here we have this is R2, right? And another thing, we have to write this. Here we have another. Okay, so this is a closed circuit, the key is closed now, so this is a closed circuit, so that maybe, or there should be, so this is negative terminal, this is positive terminal, right? So there should be a flow of current, and I is going through this circuit, and here we have R1, R2, and R3, the current flow is like this, okay. So one more thing we have to set up here, that is a voltmeter should be placed in between this. That voltmeter means the potential difference between these coils and Y. Okay. So this is the arrangement of resistors. The resistors connected in parallel. Okay. So when two or more of the resistors are connected in parallel, then what happens to the current? The current to the circuit is the sum of current flows through each branch of the circuit. So when we discuss in the case of series connection, the current is same, which is the same current is flowing through all these resistors, right? But here the current, the resultant current should be the sum of this I is divided into I1, I2 and I3. Okay, so this current should be different and the total current flowing through this circuit should be the sum of this I1, I2 and I3. Okay, and the potential difference across the points of the circuit remains the same. So the potential difference reading should be the same. Everywhere we can fix the voltmeter. Anywhere else in between these resistors, we found that the potential difference should be same in all each cases. Okay. And the reciprocal of equivalent resistance of the circuit is the sum of reciprocals of the individual resistors. So I should be the sum of I1, I2 and I3. And we know V is constant, right? That is, it will not change if it fix the voltmeter anywhere else in between these resistors. V should be a constant. So V is a constant. And from the Ohm's law, we will get what? Ohm's law, we know V is equal to IR, or we can write I is equal to what? V by R. Okay. So from Ohm's law is equal to IR, or I we can write I is equal to V by R. Right? Okay. So from this we can write I1. I1 is equal to what? I1 is equal to V is constant, but R1. I1 is this the current flowing through this resistor, the first resistor. That is I1 is equal to V by R1, and I2 is equal to V by R2. The current flowing through the second resistor, and I3 is equal to V by R3. Right? This is the current flowing through the third resistor. Okay, so now we know I1, I2, I3, and from here we can write but I is equal to V by R. If we take an equivalent resistance having the effect of all these three resistors, we can write V by R. That is I is equal to V by R. Then V is equal to what? V by R1 plus V by R2 plus V by R3. Okay, so from here this V is constant everywhere, right? So we can cut the V, or we can cancel all the V from this equation, and then what we will get 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is what we said, that the reciprocal of equivalent resistance, is equal to the sum of reciprocals of the individual resistors in this circuit. Okay, that means this is the sum of the reciprocals of individual resistors. Okay, so this is how parallel connection comes. Okay, so we can just go through your textbook. Okay, look into the page number 230. Now let us consider the arrangement of three resistors joined in parallel. Such a combination of cells or battery as shown in figure 12.7, that is given in the page number 210. The series connection and also parallel connections are given to you in this figure 12.7. These resistors are connected in parallel. Okay. And activity 12.6. Make a parallel combination XY of three resistors having resistance R1, R2 and R3 respectively. Okay. So connect it with a battery and a plug and an ammeter as shown in figure 12.10. That is given in this page number 2 also. Okay. And plug the key and note the ammeter reading. Let the current be I. Okay. So first we plug the key and note the reading of ammeter. That current is I. Okay. So that is the resultant current. Okay. And also take the voltmeter reading. That is, we have to take the voltmeter reading also. And it gives the potential difference V across the combination of these three resistors. Okay. And this can be checked by connecting the voltmeter across and now we can check the voltmeter reading, that is individual resistors. In between the individual resistors we can connect the voltmeter also. Okay. So then only we can measure the voltmeter reading, but when we see that voltmeter reading should show the same readings in all cases, right? Okay. So take out the plug from the key and remove the ammeter and the voltmeter from the circuit. Insert the ammeter in series with a resistor R1 as shown in figure. So we have to find that these individual currents. How we can find that individual currents? From this ammeter is connected in series with this circuit, right? And first the ammeter reading will show the resultant current that flows through this circuit. The circuit having a combination of these three resistors, right? Okay. So that reading is shown by the ammeter. is the resultant current. So now we take the ammeter from here and place it here. That is ammeter we can place here. That is in parallel. Sorry, that is in series with the resistor R1. Okay. And also we can connect the voltmeter from here to here. And this is how we can measure the individual voltage, individual potential difference and individual current that is flowing through this R1 resistor. Okay. So this voltmeter reading will show same as that of the voltmeter reading as before. Okay. But the current flowing through this circuit will change. That the individual current that is flowing through R1 should be changed from that of the resultant current. Okay. And if we place this ammeter in between these two ends or anywhere between these two ends, that means the ammeter should be connected in series with R2 and voltmeter should be connected in parallel with R2. Then what we can measure the individual voltage difference and the individual current that is passing through this R2 resistor having R2 resistance. Okay, and the I3 we can find the ammeter when ammeter placed in series with R3 and the voltage we can find when it is placed or when it is connected in parallel with R3. Then individual voltage and current flowing through this third resistor also we can find. Okay, so from that findings we will find this I1, I2, I3 are different and the sum of this I1, I2 and I3 will be the I value. Okay, from this experiment we will find I is equal to I1, I2 and I3. Okay, I1, I2 and I3. And also we can find the voltmeter reading will not change anymore. Okay, that means the voltage should be constant when the resistors are connected in parallel across these points. Okay, so the voltage should be constant. And by applying Ohm's law, we will get the equivalent resistance. The reciprocal of equivalent resistance should be equal to the sum of the reciprocals of individual resistors. Okay, resistances. So that are the conclusion given by this experiment. So the example 12.8, we can look into the example 12.8 in the circuit diagram given in a figure 12.10, that is in the previous page. And suppose there are the resistor R1, R2, R3 have a value 5 ohm and 10 ohm and 30 ohm respectively. So the R1 having 5 ohm, R1 is equal to, I can write inside this circuit, R1 is equal to 5 ohm and R2 is equal to how much resistance? 10 ohm and R3 is equal to 30 ohm. Right? Okay, 30 ohm. And which are how being connected to a battery of 12 volt. So the battery having 12 volt. Okay, calculate the current through each resistor, the total current in the circuit and the total current, total circuit resistance. So we have to find I1, I2, I3 and also we have to find the sum I and also but we have to find the total circuit resistance. So the R should be found out from these data. Okay, so how we can find this? Here we have the potential difference and for the battery is 12 volt. So voltage is constant when it is connected through parallel. The resistors are connected in parallel means the voltage is constant. So V is equal to 12 volt. Right? And we have R1, R2, R3. Right? So from here we can find I1, I2 and I3 using this voltage and resistance values by the help of Ohm's law. Okay. I1. I1 is equal to 3 by R1. So what is the value? 12 by R1 is equal to 5. So I1 is equal to, what is the value of I1? I1 is equal to 2.4. 2.4 ampere. Okay, you should write the unit also. So 12 by 5, now we can find this 12 by 5. Just how many 5s are there in the, yeah, 2 5s are there in 12. That is 10, remaining 2, and we can take, there is no 5s in 2. So we make it as 20 and keep the point here. 20 contains how many 5s? 4 5s are 20. Right? So this is the answer, 2.4. Okay. So I1 is given as 2.4, and like that we can get I2 is equal to V by R2, which is equal to 12 by 10. 12 by 10 is equal to 1.2 ampere. Right? How we can divide this 12 by 10? Anything that divided by 10, we can take one decimal point to come one point, that is 1 digit left, right? Okay. So that is 1.2 ampere. 10 also divide ചെയ്യാൻ ഒരു point മാറ്റി ഒരു digit മാറ്റി point കൊടുത്താൽ if it is divided by 100, 12 by 100, how we can write 12 by 100? 12 by 100 means there are 2 zeros, right? Okay, so we have to take point into left side, making 2 digits. 2 digit മാറ്റി point കൊടുക്കണം. If it is 1000, then 3 digit മാറ്റി point കൊടുക്കണം. Then we have to give a 0 here, 0.1. Okay, this is how the multiples of division of multiples of 10. How it is easier, right? Okay. Oh, okay, leave it. So we get I2 is equal to 1.2 and I3 is equal to 12 by 30. So what is the value of 12 by 30? It is 0.4 ampere. Okay. So we get I1, I2 and I3, and the resultant current we can get by adding all these three. Okay. So what we get the value of I is equal to 2.4 plus 1.2 plus 0.4. Okay. So what is the value? 0, 1 and 2 plus 1 plus 1, 4. Okay. So I is equal to 4 ampere. We get I is equal to 4 ampere. This is the resultant current for through this circuit is equal to 4 ampere. And one more thing, we have to find total circuit resistance. So the total circuit resistance, we know the total resistance circuit is the reciprocal of total resistance is equal to 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Right? And if we know this voltage and the resultant current, from here also we can find R by the help of Ohm's law. That is R, you know, R is equal to what? V I is equal to V is equal to IR. That means here we have V is equal to IR and R we get V by I. Right? So from here we can get 12 by 4, that is equal to 3 ohms resistance. Or else we can find 1 by R is equal to 1 by R is equal to 1 by 5 plus 1 by 10 plus 1 by 30. Okay. This way we can also find 1 by R is equal to, we can get the common denominator here. That is, we can make it 30, right? That is 6 into 5. And here we have multiplied 3. Okay, so how will become 6 by 30 plus 3 plus 1, right? So what is the value? 6 plus 3 plus 1, 10 by 30. Okay. So 1 by r, from here we get what? 1 by r is equal to 1 by 30. 1 by r is equal to 1 by 3. Okay. So how we will get r? Taking the reciprocal, r is equal to 3 ohm. Okay. And this way also we can get the resultant resistance to that circuit. Okay. So that is how the example or how the question we can solve the question. Okay. So example 12.9 you should try to do and you should write it in your notebook. Okay. And we have seen that in a series circuit the current is constant throughout the electric circuit and thus it is obvious impracticable to connect an electric bulb and an electric heater in series. So, electric bulb and electric heater requires different currents. Okay. But thus obvious impracticable to connect the electric bulb and electric heater in series. These two ones what different voltage is different voltage to or different current to work. ഒരു ബൾബിന് വർക്ക് ചെയ്യാൻ വേണ്ട കറണ്ടായിരിക്കില്ല ഒരു ഹീറ്ററിന് വർക്ക് ചെയ്യാൻ. So that is the disadvantage of series connection that we have already discussed in the previous class. Okay. So because they needs current widely different values to operate properly. Another major disadvantage of series circuit is that one component fails, the circuit is broken and none of the components works. And all things we have discussed in the later class, in the previous class. If you have used a fairy lights to decorate a building on festivals, one marriage celebrations, etc., you might have seen that electrician spending a lot of time to trouble locating and replacing the dead bulb. Okay, so these are connected in series. When one is broken up or one is fused, then all the circuit will be broken, right? Okay, so it is too much difficult to replace that bulb. Each has to be tested to find which has fused or not. On the other hand, a parallel circuit divides the circuit through the electrical gadgets. That means a parallel connection divides the current through the electrical gadgets. So we can find the current passing through all these gadgets are different, right? Okay, so we can find or we can make use of this parallel connection when connecting the heater and bulb. That means they require different currents, right? So we can fix them in parallel connection. Okay. So the total resistance in a parallel circuit is decreased. This is helpful for particularly when each gadgets are different resistance and require different current to operate properly. So different currents, different resistance ഉള്ള gadgetsന് different current ആയിരിക്കും അത് വർക്ക് ചെയ്യിക്കാൻ വേണ്ടി വരാം. Okay, so these gadgets can be placed together when they connected in parallel connection. Okay, so that is how parallel connection is more advantage from that of series connection. Okay, so parallel arrangements divides current in different branches and hence each component receives the required amount of current. If one of the component fails in the parallel circuit, the rest works as usual. Okay, so series connection പോലെയല്ല parallel connection one of the components may that means no other components affected. മറ്റുള്ള കമ്പോണൻസിനെ അഫക്റ്റ് ചെയ്യുന്നത് they work as they are before. അവര് നോർമലായി വർക്ക് ചെയ്തിരിക്കും. ഡെഡായി പോയ കമ്പോണന്റ് മാത്രം നമുക്ക് റീപ്ലേസ് ചെയ്താൽ മതിയാവും. അതാണ് പാരലൽ കണക്ഷന്റെ ഒരു അഡ്വാൻറ്റേജ് എന്ന് പറയുന്നത്. ഓക്കെ, സോ സീരീസ് കണക്ഷന്റെ ഡിസഡ്വാൻറ്റേജ് എല്ലാം ഓവർകം ചെയ്യാൻ പാരലൽ കണക്ഷനെ കൊണ്ട് സാധിക്കും. ഓക്കെ, so that is all about parallel connection and series connection. So you should try to do the questions given, that is in page number 216, questions 1 to 5, 1, 2, 3, 4 and 5. Okay, if you cannot do or you try to do that questions, if you feel any difficulty, we can discuss it through WhatsApp. Okay. So now we are going to discuss the heating effect of electric current. Okay. So what is heating effect of electric current? Heating effect of electric current, that means whenever an electric current is passing through, or whenever an electric current is passing through a circuit, what happens? There is some current of some sort of dissipation of energy, dissipation of source energy in the form of heat is happening. That is, whenever a current flow through a circuit, some amount of energy, some amount of source energy is dissipated in the form of heat. That is known as heating effect of electric current. Okay. So source energy means that the source that we given to the circuit to produce the potential difference or to give the current flow through that circuit. That is the source energy. So some of the source energy is dissipated in the form of heat when an electric flow or electric charges flow through a circuit. Heat energy is produced. So this effect is known as heating effect of electric current. Okay. So here you have, we know that battery or cell. Here we will discuss how the heat energy or how it is. The heating effect, heating effect is produced and sometimes, and how we can utilize this heating effect of electric current in our day-to-day life. Right? So that we will discuss and go through your textbooks. We know that a battery or a cell is a source of electrical energy. Okay, battery or cell is an electrical source, the source of electrical energy. The chemical reaction within the cell generate the potential difference between the two terminals that sets the electrons in motion to flow the current through a resistor or a system of resistors connected to the battery. Okay, so inside the battery or cell there should be a chemical reaction that happen inside that battery. Okay, so due to that chemical reaction, it provides or it makes the electrons to flow through the circuit, or electrons are generated inside that cell or battery, and they can flow out and will make some potential difference. Okay. So the electrons in motion to flow the current through a resistor or a system of resistors connected to the battery. And we have also seen that to maintain the current, the source has to keep expending its energy. And where does this energy go? To keep the circuit, or to maintain this current, the source you may use the source as a battery or cell. This battery or cell have to give energy to maintain current flow through that circuit, right? So how does this current is used up, or how does this energy is used up by the circuit or the components found in that circuit? That we have to study. Okay. So a part of energy or a part of the source energy in maintaining the current may be consumed into useful work, like rotating the blades of an electric fan. That is, the electric fan or electric motor or mixie, that all things need electricity to work, right? Okay, so some amount of work, some amount of energy utilized for doing work, and another some amount, rest of the source energy may be expended in heat to rise the temperature of the gadgets. Okay, so you would have experienced the heating or some kind of heat is produced when the fans are continuously rotating or the mixing continuously working, then we can find some heat. When we touch that mixer jar, we can feel some heat, right? So that means some amount of energy is dissipated in the form of heat. Okay, so dissipation of that source energy in the form of heat is known as heating effect of electric current. Okay, so that is the rest of those energy may be expended in heat to rise the temperature of the gadget. We often observe in this in our everyday life. For example, an electric fan becomes warm if used continuously for longer time. Okay, so that are things you may experience there. Okay. So, and on the other hand, resistors only connect to a battery. The source energy continually gets dissipated entirely in the form of heat. This is known as heating effect of electric current. So, this effect is utilized in devices such as electric heater and electric iron, etc. Okay, so electric heater, electric irons heating effect of electric current ആണ് യൂട്ടിലൈസ് ചെയ്യുന്നത്. ഹീറ്റിംഗ് എഫക്ട് ഓഫ് ഇലക്ട്രിക് കറന്റ് യൂട്ടിലൈസ് ചെയ്ത് വർക്ക് ചെയ്യുന്ന ഇലക്ട്രിക്കൽ അപ്ലയൻസ് ഇലക്ട്രിക്കൽ ഗാഡ്ജറ്റ്സ് ആണ് ഹീറ്റർ, ഇലക്ട്രിക് ഹീറ്റർ ഒക്കെ. ഓക്കെ, so consider a current I flowing through. So we have a circuit that having some resistors are connected in series or parallel, and we have here we can take a circuit having a resistance, having a resistor, okay, and next one, here we have a voltmeter. Okay, this is the resistor. Okay, so how the energy is dissipated in the form of heat. That is, the current flowing through this circuit is I, right? The current flowing through this circuit is I, and the resistor having a resistance R, and let a potential difference across it be V. Okay, so this is, we can take this V, the potential given by the cell is V, and let T be the time during which a charge Q flow across. That means a charge Q flow across this circuit within a time T, right? Okay, so the work done to bring or work done to moving a charge Q through the potential difference V, a charge Q is to be drawn through a potential difference V within a time of T. We can write as the work done is, we can write it as QV, right? The work done to move a charge Q across a potential difference V is, we can write it as QV, right? Okay, so the work done moving a charge Q through a potential difference V is QV or PQ. Okay, and therefore the source must supply energy equal to VQ in time T. Okay, so the source must be supply an energy that is equivalent to VQ, within a time of T, to bring that charge, to move that charge through the potential difference V within a time of T. Okay, so here the power input to the circuit by the source is power. You know, power is always, we can write power is the work done per time. Okay, power input we can write power is equal to work done by time. Okay, so power, we know, it is the work done by time. Okay, so what is the power input? We can write this W as Q V by T. Okay, So now you know what is 2 by T, charge divided by time, that is current. How many charge going through a cross-sectional area within a time of time, within a time of T, that is known as current, right? Okay, so here we can write V is equal to what? VI. Okay, the power is now we can write it is a VI. Okay, so power we get as VI. So the energy supplied to the circuit, or the energy supplied to the circuit, what we can write? It is power, this power into the time. How much time? That is T time. Okay. The energy supplied to the circuit by the source in time T is the energy supplied. The energy supplied. The energy supplied by the source we can write as P into T. Okay. And now we know what is P. P we know. I can write here P we know is equal to VI. So the energy supplied by the source is we can write this as or VIT, right? So the energy supplied by the source in a time T we get it as VIT. Okay. So what happens to this energy expended by the source? This energy gets dissipated in the resistor as heat. So this much of energy is utilized for the heating effect. Okay, so this amount of energy is dissipated in the form of heat. Okay, so we can write the heat energy or thus for a steady current I, the amount of heat produced in time T, we can write heat produced H is equal to VIT. H is equal to VIT. And from Ohm's law, we know what is V. V is equal to IR. Right? From Ohm's law, we know V is equal to IR. And substitute this IR into this V. And H is equal to IR into IT. Right? So we can write H is equal to I square RT. Okay. So H is equal to I square RT. H is equal to I square RT. This is the Joule's law of heating. Okay. Joule's law of heating gives the heating effect, the heat energy is equal to I square into RT. Okay, so this is known as Joule's law of heating, and the law implies that the heat produced in a resistor is directly proportional. The heat produced in a resistor, the heat produced in this resistor is directly proportional to the square of the current flowing through this resistor, right? And it is directly proportional to the resistance of this resistor and also the time that the time that the current flow through that resistor. Okay. So the law implies, the Joule's law of heating implies that the heat produced in a resistor is directly proportional to the square of the current for a given resistance and directly proportional to the resistance for a given current and directly proportional to the time for which the current flow through the resistor. And in practical situations, when an electric appliance is connected to a non-voltage source is used after calculating the current through it using the relation I is equal to V by R. So this heating effect has some importance in our day-to-day life experiences, day-to-day life examples. Okay, that means fuses are there in our homes, right? So what is a fuse? What does the fuse do? എന്താണ് ഒരു ഫ്യൂസിന്റെ ആക്ച്വൽ യൂസ് എന്താ? right? The overflow current overflow ആയി കഴിയുമ്പോൾ ആ ഫ്യൂസിൻ്റെ ഉള്ളിലുള്ള വയർ ഹീറ്റായി അത് ബ്രേക്ക് ആയി, right? So that overflow means current overflow ആയി കഴിഞ്ഞാൽ some gadgets may be fused up, or some gadgets may affect this overflow of current harmful, right? So current overflow ആവുന്ന ടൈമിൽ ഫ്യൂസ് എന്ത് ചെയ്യും, ആ ഫ്യൂസ് വയർ ഹീറ്റ് ചെയ്ത് ഉരുകിപ്പോകും, right? That means the heating effect was there, okay, and the coil or the wire inside that fuse burns due to this heating effect, and the circuit will cut off, or the current will cut off, and then it will make safe to us. And that is a use of fuse, and how fuse is working with the help of this heating effect, okay. And all the when the electric appliances are connected to a non-voltage source, that means the voltage source, we know the voltage source, right? The voltage source given to home appliances and the home appliances and the electrical appliances, electrical gadgets used in factories and like that is they need different voltage, right? So we know that the voltage given to us, okay. So the for a non-voltage source, it is used after calculating the current through it. So ഒരു പെർട്ടിക്കുലർ കറണ്ട് ആ വോൾട്ടേജിനെ ക്യാരി ചെയ്യാൻ, വോൾട്ടേജ് സോഴ്സിനെ സപ്ലൈ ചെയ്യാൻ പറ്റുന്ന കറണ്ട് നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്യുന്നു. That means I is equal to V by R from Ohm's law, I is equal to V by R. Okay, so we used after calculating the current through it using the relation I is equal to V by R. Then only we can find the heating effect. Okay, that heat energy produced is equal to I square R. Okay, that means heat I increasing I means current increases. Current double ആയി കഴിഞ്ഞാൽ heating effect 4 times out, right? Okay, that means higher current ആണ് പാസ് ചെയ്യുന്നതെങ്കിൽ high heating effect ആയിരിക്കും ഉണ്ടാവുക. So we have to choose the appropriate current and for a particular voltage. Okay, that is safe to our electrical appliances and all the things inside the phones also. Okay, so that is it is safe to use by calculating the current using V by R. Okay, so these are about the heating effect of electric current. And example 12.10, look into the example 12.10. An electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate, and 360 watt when the heating is at the minimum. The voltage is 220 watt, and what are the current and the resistance in each case. So here the power is given, and we have to find the current and the resistance in each cases. So from equation equation, that is the equation of power, we know power is equal to VI, right? We know power is equal to VI. Okay, and thus the current I, we can get the current from this equation. How we can find? P by V will give the current. Okay, so this will give the current. And when heating is maximum rate, what is the heat? An electric iron consumes energy at a rate of 840 watt when the heating is maximum rate. Okay, so the P is equal to 840 watt when heating is maximum, right? And when heating is minimum, or heating is minimum, this is maximum, and heating is minimum, P is equal to 360 watt, right? So we have to find, we have to find the current and resistance in each case. So we have to find I in each case, and voltage we know it is 220 volt. Okay, voltage we know it is 220 volt. Okay, so P max, that at first we have to find I when the electric iron works heating at a maximum rate. So I max is equal to I max, we can write I max is equal to P max. P max is equal to 840 watt divided by 220 volt. Right? Okay. So what will be the value? What will be the value? The value should be 3.82 ampere. Right? 3.82 ampere. The I max is equal to 3.82 ampere. And I minimum, we can write this as what is the minimum power, the heating oil at minimum heating, the heating electric iron when it works at minimum heating, 360 watt is produced, and 360 divided by 220 volt, and what will be the value? The value should be 1.6 ampere. 1.64 ampere. Okay. 1.64 ampere is the I minimum. And now we get I maximum and I minimum. And what we have to find the resistance of each case. So the resistance of each case, how we can find? Now we know V and I. And from Ohm's law we can find R is equal to, from Ohm's law, V is equal to IR and R is equal to V by I. So in each case, here we can get the R as I max is 3.82 and V is equal to 2.8. So in first case, that is the electric iron at maximum heating, we get R is equal to 220 divided by 3.82. Okay, so what is the value? 220 divided by 3.82 will give 57.60 ohm. Okay, and when it is minimum, if we have minimum heating, then we can write R is equal to V is equal to 220 divided by this 1.64 is equal to, what is the value? 134.15 ohm. Okay, so this is the integer the resistance in each cases and the current through them in each cases. Okay, so this is how we can find the or we can solve the problems by using heating effect of electric current. Okay. So example 12.11 you should write in your notebook, and also the questions 1, 2, 3 given in page number 218. Page number 1, 2, 3 questions. So you should try to find the answers. Okay. If you feel any difficulty by doing these problems, you can ask me. Okay. So that is all about today's class, and hope you are clear how the parallel connection, how the resistors are connected in parallel connection, and how the voltage difference or the current difference or the resistance, the receptor resistance, current and the voltage, how comes it in parallel connection, and what is the advantages of parallel connection over series connection. That all can see how discussed today. Right, and the heating effect of electric current also we studied in this class. Okay, so keep doing the problems and keep reading your textbooks thoroughly. Okay. Okay. So we can meet in the next class. Children, take care and goodbye. Thank you.